Download this code from codegive.com, link in the description below. Remediation of XML external entity, XXE, injection, a comprehensive tutorial. XML external entity, XXE, injection is a serious web security vulnerability that allows attackers to inject malicious XML code into an application that processes XML input. This allows them to read arbitrary files, gain access to sensitive files on the server, including configuration files, source code, and even password databases. Perform server-side request forgery, ssrf, make requests to internal or external services on behalf of the server. Denial of service, DOS, cause the server to crash or become unresponsive. Code execution, in some cases under specific configurations and if the application parses and executes dtds, document type definitions, attackers might achieve code execution. This tutorial will cover 1. Understanding XXE vulnerability, a detailed explanation of how XXE works and the different types of attacks. 2. Identifying XXE vulnerabilities, methods for discovering XXE vulnerabilities in your applications. 3. Remediation strategies, comprehensive guidance on preventing XXE attacks, including practical code examples in various programming languages, Java, Python, PHP. 4. Input validation and sanitization, techniques for cleaning and validating XML input to mitigate risks. 5. Secure XML parser configuration, proper configuration of XML parsers to disable or restrict external entity processing. 6. Regular security audits and penetration testing, importance of ongoing security assessments. 7. Best practices, general recommendations for developing secure XML processing code. 1. Understanding XXE vulnerability. At its core, XXE exploits the way XML processors handle external entities. XML documents can define entities, which are named placeholders that can be expanded when the XML is parsed. External entities, specifically, refer to resources outside the main XML document. Basic XML structure *. Entities Entities are defined within the XML document using the entity syntax. Internal entities defined within the XML document itself. External entities defined using a URI, Uniform Resource Identifier, pointing to an external resource, file, URL, etc. The XXE vulnerability arises when 1. The XML parser is configured to allow external entities. This is often the default setting in older versions of many XML parsers. 2. The application takes XML input from a user and processes it without proper validation or sanitization. Types of XXE attacks reading arbitrary files The most common type of XXE attack. The attacker crafts an XML document with an external entity that points to a sensitive file on the server. When the server parses the XML, it reads the contents of the file and includes it in the response, or processes it in some other way that allows the attacker to retrieve it. Example: server-side request forgery, ssrf. The attacker uses an external entity to make requests to internal or external services that the server can access. This can be used to bypass firewalls, access internal resources, or scan the internal network. Example: denial of service, DOS. By crafting a malicious XML document with recursively defined entities, a billion laughs attack, an attacker can consume excessive resources, CPU, memory, and cause the server to crash or become unresponsive. Example: billion laughs. Asterisk code execution, less common, requires specific conditions. If the application uses a DTD, document type definition, and parses it, which is generally not recommended, an attacker might be able to leverage the DTD to execute code. This is typically more complex and requires specific configurations of the XML parser and the underlying system. 2. Identifying XXE vulnerabilities. Identifying XXE vulnerabilities requires careful analysis of how your application handles XML data. Here's a breakdown of methods. Asterisk code review asterisk. The most reliable way to identify XXE vulnerabilities is to thoroughly review your application's source code. Look for places where XML data is parsed, and pay close attention to the configuration of the XML parser. Specifically, check if external entities and DTD processing are enabled. Asterisk dynamic testing, penetration testing. This involves sending crafted XML payloads to the application and observing the responses. You can use tools like Burp Suite, OWASP-Zap, or custom scripts to automate the testing process. Here's how to test for XXE. 1. Identify XML input points *. Look for endpoints that accept XML data, example SOAP APIs, XML-based configuration files, upload forms. 2. Craft a basic XXE payload *. Start with a simple payload to read a common file, like /etc/password on Linux/Unix systems or c/boot.ini on Windows. 3. Send the payload and analyze the response *. If the application is vulnerable, the response might contain the contents of the requested file or an error message indicating that the file was accessed. Example. Request. Successful vulnerability indication, response might contain. 4. Test for ssrf *. If you can read local files, try ssrf by pointing the external entity to internal URLs, example http://localhost 8080/admin. Monitor the server logs to see if the request was made. 5. Test for DOS *. Use the billion laughs attack to try and overload the server. Static analysis tools *. Static analysis tools can automatically scan your code for potential XXE vulnerabilities. These tools analyze the code without actually running it, so they can identify potential issues early in the development life cycle. Examples include SonarCube, Fortify, and Checkmarks. Web application scanners *. Some web application scanners, like Burp Suite Professional, OWASP-Zap, and Neshes, can automatically detect XXE vulnerabilities during web application scans. These scanners typically send a variety of XXE payloads to the application and analyze the responses to identify potential vulnerabilities. 3. Remediation strategies. The most effective way to prevent XXE vulnerabilities is to disable or restrict the use of external entities and DTD processing in your XML parsers. General recommendations *. Disable DTD processing *. This is the most effective defense. DTD processing is rarely needed in modern applications, and disabling it eliminates a major attack vector. Disable external entities *. If you absolutely need to use entities, disable external entities while still allowing internal entities. This limits the scope of the attack. Use a safe XML parser configuration *. Configure your XML parser according to the language-specific instructions below. Input validation and sanitization *. Validate and sanitize XML input to prevent malicious code from being injected. While this is not a replacement for disabling external entities, it can provide an additional layer of defense. Principle of least privilege *. Run the application with the minimum necessary privileges. This limits the impact of a successful XXE attack. Web Application Firewall, WAF. A WAF can help to detect and block XXE attacks. However, a WAF should be considered an additional layer of defense and not a replacement for proper coding practices. Keep libraries and frameworks up to date. Ensure that your XML parsing libraries and frameworks are up to date with the latest security patches. Language-specific examples. Java * using javax.xml.parsers.document builder factory *. Explanation *. Factory.set feature, http://apache.org/xml/features/disallow.type true, this is the most important setting. It disables DTD processing, effectively preventing XXE attacks. Factory.set feature, http://xml.org/sax/features/external general entities, false, disables external general entities. Factory.set feature, http://xml.org/sax/features/external parameter entities, false, disables external parameter entities. Factory.set feature, http://apache.org/xml/features/non-validating/load external DTD, false, prevents loading external DTDs even if disallow.type is not set, for extra safety. Using javax.xml.stream.xml input factory, stacks. Explanation Factory.set property, XML input factory.support_DTD, false, disables DTD support. Factory.set property, http://xml.org/sax/features/external general entities, false, disables external general entities. Factory.set property, http://xml.org/sax/features/external parameter entities, false, disables external parameter entities. Python **** using LXML, recommended. Explanation **** resolve_entities equals false, disables the resolution of external entities. This is the critical setting to prevent XXE. *No_network equals true, prevents LXML from accessing the network. This is a good practice to further mitigate ssrf risks, even if entities are disabled. Using xml.itree.elementtree, less robust. Explanation forbidden_DTD equals true, disables DTD processing. It relies on a custom tree builder target for parse function, otherwise a DTD is not forbidden and the vulnerability still occurs. Using io.bytes.io to create an in-memory file-like object from the XML_data which should be a byte string. Important considerations for xml.itree.elementtree xml.itree.elementtree is generally less secure than LXML for handling untrusted XML data. It has had a history of vulnerabilities, and its mitigation options are less robust. LXML is highly recommended over xml.itree.elementtree whenever possible. PHP ** using libxml_disable_entity_loader, PHP 5.x. Explanation ** libxml_disable_entity_loader, true, this globally disables external entity loading for all XML parsing operations using the libxml library in the current script. This is crucial. Using DOM document load XML, with libxml_no end and libxml_valid flags, PHP 5.x and 7.x. While libxml_disable_entity_loader is preferred, using the libxml_no end and libxml_valid flags can provide some protection, although less robust. Use them in conjunction with libxml_disable_entity_loader, when possible. Explanation asterisk. Asterisk libxml_no end replaces entity references with their actual values as the XML is loaded. This can help prevent external entity injection, but it's not a complete solution if libxml_disable_entity_loader is not enabled, because entity substitution can still introduce other vulnerabilities. Asterisk libxml_valid, enable DTD validation. This is not a security feature in itself, but it can help to detect invalid XML structures and potentially prevent some types of attacks. However, relying solely on DTD validation is not sufficient to prevent XXE. Asterisk libxml_net prohibits network access during DTD validation. This adds a layer of protection against ssrf if DTD validation is enabled. Important PHP considerations asterisk. Asterisk libxml_disable_entity_loader is the primary defense against XXE in PHP. Always use it. Asterisk combine libxml_disable_entity_loader with the libxml_no end, libxml_valid and libxml_net flags for DOM document load XML to provide additional layers of defense. Asterisk be aware that even with these mitigations, PHP's XML handling can be complex. Always thoroughly test your code to ensure that it is not vulnerable. 4. Input validation and sanitization. While disabling external entities is the most effective approach, input validation and sanitization can provide an additional layer of defense. However, do not rely on input validation alone to prevent XXE. It's very difficult to create a foolproof input validation mechanism that covers all possible attack vectors. Techniques for input validation asterisk. Asterisk schema validation asterisk use an XML schema, XSD, to define the structure and content of the expected XML data. This allows you to validate the XML input against a predefined set of rules and reject any XML that does not conform to the schema. Example, Java. Schema.xsd example asterisk. Asterisk whitelisting asterisk define a strict whitelist of allowed elements, attributes, and attribute values. Reject any XML input that contains elements or attributes that are not on the whitelist. This is more restrictive than schema validation but can be useful in some cases. Asterisk blacklisting asterisk attempting to blacklist specific characters or patterns that are known to be used in XXE attacks. This is generally not a reliable approach because attackers can often find ways to bypass blacklists. Important considerations for input validation asterisk. Asterisk schema validation is the most effective form of input validation for XML. Asterisk do not rely on blacklisting alone. Asterisk input validation should be used in addition to, not instead of, disabling external entities. 5. Secure XML parser configuration. The specific steps for configuring an XML parser to be secure depend on the programming language and the XML library that you are using. Refer to the language-specific examples in the Remediation Strategies section for detailed instructions. Key configuration points asterisk. Asterisk disable DTD processing asterisk this is the most important step. Asterisk disable external entities asterisk disable both external general entities and external parameter entities. Asterisk disable network access asterisk prevent the XML parser from accessing the network. This can help to mitigate ssrf risks, even if external entities are disabled. Use the latest versions. Ensure that you are using the latest versions of your XML parsing libraries and frameworks. These versions often include security patches and improvements. 6. Regular security audits and penetration testing. Regular security audits and penetration testing are essential for identifying and addressing XXE vulnerabilities and other security risks in your applications. Security audits. A security audit involves a comprehensive review of your application's source code, configuration, and deployment environment to identify potential security vulnerabilities. Penetration testing. A penetration test involves simulating a real-world attack on your application to identify and exploit vulnerabilities. This can help you to identify weaknesses that might not be apparent from a code review or static analysis. Best practices for security audits and penetration testing. Use qualified security professionals. Engage experienced security professionals to conduct your security audits and penetration tests. Test regularly. Conduct security audits and penetration tests on a regular basis, especially after making significant changes to your application. Automated scanning. Employ automated vulnerability scanning tools to proactively identify common XXE and other web application vulnerabilities. Fix vulnerabilities promptly. Address any vulnerabilities that are identified during security audits or penetration tests as quickly as possible. 7. Best practices for secure XML processing. Here are some general best practices to follow when developing secure XML processing code. Treat XML input as untrusted data. Always treat XML input from external sources, users, APIs, etc., as potentially malicious. Prefer simpler data formats. Consider using simpler data formats like JSON if XML is not strictly necessary. JSON generally has a smaller attack surface. Keep libraries updated. Regularly update your XML parsing libraries and frameworks. Implement logging and monitoring. Log all XML processing events and monitor the logs for suspicious activity. Education and training. Provide security training to your developers to help them understand XXE vulnerabilities and how to prevent them. In summary, the key to preventing XXE vulnerabilities is to disable or restrict the use of external entities and DTD processing in your XML parsers. Combine this with input validation, regular security audits, and secure coding practices to build robust and secure applications.